Okay, in this video, I'm going to show you how to determine if two triangles are congruent. Whenever we say two triangles are congruent, it means they have the same size, but at the same time, they must have the same shape. So these two conditions should be satisfied. Same size, same shape. Now, in most cases, the question would be, you will be given two triangles and you have to determine if the two triangles are congruent. In actual or physical triangles, it's very easy to identify if the two triangles are congruent by simply putting one triangle on top of the other. So if it will turn out that they will be in the same, like you will see that they are exactly the same size and the same shape, then that means they are congruent. But what if you are given triangles that are drawn and you have to determine whether the two triangles are congruent? So how do we identify if they are really congruent? So the question is how to identify if the triangles are congruent. So first thing is you have to note some principles in geometry, specifically on congruence triangles or on the triangle congruence. You need to satisfy the following postulates. The first one is what we call the SSS. The second one is SAS. The third one is ASA. So these are postulates. So properties that will tell you if the two triangles are congruent. And you also have theorem or theorems. The first one is AAS and the second one is HL. Okay, so what does it mean when we say SSS? So SSS stands for side, side, side. It means if all the sides of a given triangle are the same with the corresponding sides on a second triangle, then the two triangles are congruent. So what do I mean by that? So if this side is equal to this side, and this side is equal to this side, and this third side is equal to the third side of the second triangle, then by SSS, the two triangles are congruent. Now, for the case of SAS, so this means side, angle, side. So note how the A is positioned in between the two sides. Okay, it means the angle should be between the two sides that are equivalent to the corresponding side of the second triangle. So if this is by SSS, for the case of SAS, so if we will make another pair of triangles, say let's make a different orientation. So SAS means if I can find one side equal to one side of the second triangle, and then say there's a second side also equal to another side of the second triangle, and if the angle between these two sides is equal to the angle in between of these two sides, then by SAS, the two triangles are congruent. It came from the side, there's the angle, and there's the side. Side, angle, side. So that is how we use side, angle, side postulate. In the same way, so the third postulate is ASA. So let's create two triangles again. So this triangle as compared to this triangle. ASA means if I know that this angle is equal to this angle, and this angle is equal to this angle. So note, I have two corresponding angles that are the same. So if the side in between the two angles is equal to the side in between the two angles on the second triangle, then by ASA, angle, side, angle, we can also say that the two triangles are congruent. They are the same size, and same shape. So that's how you understand the three postulates. So angle, there's a side in between, so you cannot have a side that is not in between the two angles. So angle, side, and the second angle. Angle, side, and a second angle. By ASA, the two triangles are congruent. Okay, so I hope that is still clear. Now, what about AAS? So these are theorems. It means they came from the three postulates. So for AAS, let's start with AAS. Let's create another pair of triangles. Say this way. Suppose I know that this angle is equal to this angle, and this angle I also know, or it's indicated in the two figures, that is equivalent or equal to the second angle. And if this side is equal to this side, if you follow it, this is an angle, and a side. And on the other hand, or on the other triangle, we have the angle, and a side. By AAS, the two triangles are congruent. Okay? And then the last one is, suppose I have two right triangles. Let's say this triangle, and then there is a second triangle, which is also a right triangle. We can identify, or we will know, if two right triangles are congruent by simply satisfying what we call the HL theorem. H stands for hypotenuse, and L stands for the side, or one of the sides of the triangle. So in this case, you have to take note that this theorem will only apply if the two triangles are right triangles. So how will we use the HL theorem? Suppose we know that the hypotenuse of this first triangle is equal to the hypotenuse of the second triangle. So we were able to satisfy the H. Now if this side is equal to this side, then automatically by satisfying hypotenuse and the leg, so L stands for the leg, one side of the triangle, then we can already conclude that the two triangles are congruent. So as you can see, these postulates actually are giving you a faster way on identifying triangles. The longer way is, of course, you have to measure each side, and then if all the sides of the first triangle are the same with the sides of the second triangle, then you can say the two triangles are congruent. But in most cases, you will be given information such as you know two sides, you know an angle, you know two angles, and you know a side. If that will happen, you don't have to measure all the sides, you don't have to measure all the angles. All you have to do is to see if SSS will work, SAS will work, ASA will work, AAS will work, or HL will work. Okay? Now, let's apply these ideas on some examples. Okay, so here we have four problems on identifying if two triangles are congruent. So the question is, or the problem is, name a triangle congruent to the given and state the case of congruency. So the state, or the case of congruency are SAS, SSS, ASA, AAS, and HL theorem. So let's apply the postulates and the theorems here. So in letter A, it says the angle A is equal to the angle E. The angle C is equal to angle F. And then the side, or one side of the triangle, so this one, is also equal to one side of the second triangle. If we will check, this is an angle, this is an angle, and this is a side, then we were able to see, or we can see that we were able to satisfy the AAS theorem. So that means the two triangles are congruent. So in short, once you see that any of the postulates or theorems will be satisfied, then you can conclude that the two triangles are congruent. Now here, so how do we say the congruence? The triangle ABC is equal to the triangle blank. Now in stating congruences, you have to follow a specific order. So notice how I labeled angle A as one circle, angle C as two circles, and the side as three circles. So that I will have an easy way on naming the congruence. So first circle, or one circle, two circles, three circles. And then here you have one circle, two circles, and three circles. Then triangle ABC must be congruent to E, F, and B in this proper order. The triangle ABC, so as you can see, ABC, A goes to B without any symbol, and finally to the C. So if I will name the congruence, so that means from the first circle to the angle with no circle, and then down to the last point, which is F. So triangle ABC is congruent to triangle E, D, and F. As you can see, AB is congruent to ED. The side AB from one circle to the point with no symbol should be equal to the side E with one circle to the point with no symbol. So order is important in naming the congruence so that you will know which side and which angles are corresponding to each other. We'll end the video on this first example. In the second video, I'm going to show you how to determine whether these two triangles are congruent, these two triangles are congruent or not, and letter D, if the triangle ABC is congruent to the second triangle here. Okay, so that's all for now. So you have to check the second video.